You are listening to Ayomide, where complex idea becomes simple. There's something sitting in your pocket right now, or on your desk, or open in another tab on your screen. Use it to write, to search, to create, to think. And most people who use it every single day has never stopped to ask one simple question. Where did this come from? How was the artificial intelligence actually created? Today, I want to answer that question simply because the story is more interesting than most people know. Let us go back to the beginning, not to Silicon Valley, not to the smartphone era, all the way back to 1936. A young British mathematician named Alan Turing is sitting with a question that sounds almost philosophical. Can a machine think? Now, at the time, that question seemed absurd to most people. Machines did physical work, they moved things, they calculated numbers mechanically. But think, reason, understand. Most scientists of that era would have laughed at that suggestion. Alan Turing did not laugh. He sat with a question. He worked on it. He built a theoretical model of a machine that could process information, follow rules, and produce intelligent output. He called it the universal computing machine. We call it the computer. But Turing went further than the computer. In 1950, he published a paper, and in that paper, he asked a question that would define the next 70 years of scientific pursuit. Can machines do what we, as thinking beings, can do? He proposed a simple test. If a machine could carry on a conversation with a human being, and the human being could not tell whether they were talking to a machine or a person, then that machine could be said to think. We call it the Turing Test, and it became the North Star of artificial intelligence research for decades. Now, here is something I want you to understand. The path from that question in 1950 to the AI tools you use today was not a straight line. It was not a smooth journey of steady progress. It was decades of enthusiasm. Sorry, I pronounced that wrongly. Followed by failure, followed by abandonment, followed by renewed hope, followed by failure again. In 1956, a group of scientists gathered at Dartmouth College in New Hampshire. They coined the term artificial intelligence, and they were optimistic, deeply optimistic. They believed that within a generation, machines would be able to do everything a human mind could do. They were wrong, not because the dream was impossible, but because they had underestimated how complex human intelligence actually is. The years that followed became known as the AI winters, period of time when funding dried up, when government lost interest, when the scientific community largely abandoned the field because the promises had not been kept. The machines could not learn, not really. They could follow rules, they could calculate, but they could not adapt. They could not generalize. They could not do what the human brain does effortlessly every single moment of every single day. But a small group of scientists kept working quietly, without much recognition, without much funding, and they were working on something specific. They were working on the idea that the brain itself could be a model for machine intelligence. The human brain is made of neurons. Billions of neurons connected to each other, firing signals, forming patterns, learning from experience. What if a machine could be built the same way? Not with biological neurons, but with mathematical ones. They call the concept a neural network. And the idea was simple enough to explain in one sentence. A system that learns not by being programmed with rules, but by being shown examples. Thousands of examples, millions of examples, until it begins to recognize patterns on its own. Think about think about how a child learns to recognize a dog. Nobody sits the child down and explain a dog has four legs, four, a tail and backs. The child simply sees a dog again and again in different shapes, different size, different colors, and eventually the child's brain builds a pattern. That is a dog. Neural networks learn the same way. Show them enough examples and they begin to understand. But here is the thing about neural networks. The idea was not new. Scientists had been working on it since 1940s. The problem was not the concept. The problem was the data and the computing power. To train a neural network properly, you need enormous amounts of data. And you need computers powerful enough to process that data. In the 1980s, neither of those things existed at the scale required. Therefore, the breakthrough did not come from a new idea. It came from the world catching up to an old one. In the 2000s, the internet created something that had never existed before in human history. Data, vast, incomprehensible, almost infinite amounts of data, text, images, video, conversations, transactions, behavior. Billions of humans creating information every single second. And at the same time, computing power was growing exponentially. Graphics cards, original design for video games, turned out to be extraordinarily efficient at the kind of calculations neural networks required. Everything converged: the old idea, the new data, the computing power, and in 2012, a neural network called AlexNet won an image recognition competition by emerging so large that the scientific community stopped and arguing and started paying attention. The AI winter was over. What followed was the decade that built the world you live today. Google, Facebook, Amazon, OpenAI, each racing to build larger networks, training on more data, producing more capable systems. Until one day, not very long ago, you opened a conversation window and a machine answered you, not with a pre written response, not with a list of search results, but with thoughts, with context, with something that felt remarkably like understanding. Artificial intelligence was not invented in a boardroom, it was born from a question. A simple, stubborn, endlessly pursued question that refused to go away. Can a machine think? And the answer turns out changes everything.